NASA's James Webb Space Telescope captured new images of a horse-shaped nebula so powerful that it might have just shattered our understanding of the universe. The problem is that the James Webb Space Telescope is upsetting the apple cart. Suddenly, we realize that we may have to rewrite all the textbooks about the beginning of the universe. In the Orion Nebula, astronomers might have discovered an entirely new class of objects. One well-known star nursery is Serpens. Imagine for a second if I told you that the James Webb Telescope has discovered an anomaly in space. There are a number of such structures, not just one or two. Using information gathered by the James Webb Space Telescope, NASA has just identified 6 enormous galaxies. It's possible they may only have to revise the textbooks. Scientists are perplexed. We should examine their findings. Primacy large old galaxies. The James Webb Telescope found 6 luminous red spots against a rather mundane backdrop among the oldest and biggest galaxies discovered so far. These spots date back up to 13.3 billion years. Certainly not your average spots. The reddish hue of these 6 spots suggests they formed quite soon after the Big Bang, within the last few 100 million years. Until recently, scientists thought these structures couldn't have developed during that time. Contrary to what scientists had previously believed, the formation of stars and galaxies did not take nearly as long after the Big Bang. Since these old galaxies were already huge and teeming with star formation, one of these universe-breaker galaxies dwarfs the Milky Way by a factor of 10 and is 1 trillion times larger than our Sun. Because the cosmos didn't start the way we believed it did, the gloomy ages might not have been so gloomy after all. This finding has troubled many. Secondly, novel results from exoplanet molecule studies. Finding an exoplanet that might support life has become an obsession for astronomers. A candidate that exhibits signs of life is K218b, one of many. What gives? James Webb recently discovered carbon-bearing chemicals like methane and carbon dioxide. They also discovered water vapor in its atmosphere, so it's possible that K218b has an ocean of water and an atmosphere rich in hydrogen, ideal circumstances for life. Dimethyl sulfide was also detected, but you won't believe it until you hear this. You know who makes that stuff on this planet? Only living things. I have faith in your intelligence to see the obvious. Thirdly, where did the cosmic web come from? A cluster of 10 galaxies was discovered 830 million years after the Big Bang by astronomers utilizing the James Webb Space Telescope of the National Aeronautics and Space Administration. It's the same as discovering a cosmic picture you had as a kid. To what extent does this matter? Simply put, our present knowledge does not support the idea that these galaxies existed during that time. Evidently, that comprehension was wrong. A gigantic black hole at the heart of a galaxy known as a very quasar anchors this structure, which is approximately 3 million light-years long. It is possible that this string of galaxies may expand into a massive cluster similar to the Coma cluster that is familiar to us from our cosmic neighborhood. In the 4th place, we have early supermassive black holes. Black holes expand by devouring gas clouds, dust, and stars in motion, as you may be aware. Supermassive black holes operating in the early cosmos, even before they've had a chance to gorge themselves on their environment, have been observed by astronomers thanks to James Webb. More than that, it caught the X-ray image of the galaxy UHC1, which has the most distant black hole ever seen. That just astounds me. At a distance of 13.2 billion light-years from Earth, UHC1 allows us to observe the black hole in its early stages shortly after the Big Bang, some 470 million years ago. Astoundingly, this black hole is equivalent in mass to the sum of all the stars in its host galaxy, with an estimated mass ranging from 10 million to 100 million times that of the Sun. The Horsehead Nebula, Barnard 33, is another name for this nebula, which is located approximately 300 light-years away. The instruments on the Webb telescope have allowed scientists to observe the lighted edge of the Horsehead Nebula and its small-scale structures for the first time. Its light comes from a nearby blazing star and originated in a collapsing interstellar cloud. Even though the gas clouds surrounding the Horsehead Nebula have mostly diffused, the dense material that makes up the distinctive pillar shape is still hanging on. But astronomers think the Horsehead Nebula will be around for another 5 million years or so before it begins to dim. Now astronomers can follow the intricate patterns created by the evaporation of dust particles from clouds using ultraviolet light. The James Webb Space Telescope has revolutionized our understanding of cosmic phenomena. By closely examining the Horsehead Nebula, astronomers can better understand how stellar winds and radiation from nearby stars sculpt these massive pillars of gas and dust into intricate shapes. This provides clues about the life cycle of stars and the processes that lead to the formation of new stars. While the Horsehead Nebula has long been a subject of fascination, the advanced imaging capabilities of Webb reveal previously unseen details, allowing scientists to peer into the nebula's deeper layers, which are shrouded in mystery. Furthermore, the telescope's findings on the early formation of galaxies have shaken the foundations of cosmology. With the discovery of fully formed massive galaxies just a few 100 million years after the Big Bang, our timeline of cosmic evolution may need a significant adjustment. These early galaxies were rich in heavy elements, suggesting that star formation and chemical enrichment happened much faster than previously believed. It also challenges the notion of a slow, steady progression from the early universe's primordial soup to the intricate structures we observe today. Another groundbreaking revelation comes from the study of cosmic filaments and their role in galaxy formation. The James Webb Telescope's observations hint at a more complex and dynamic interaction between dark matter, gravity, and ordinary matter than was previously understood. These cosmic highways, which channel gas and stars into clusters, appear to have been in place much earlier than anticipated. This raises questions about the mechanisms driving their formation and their influence on the large-scale structure of the universe. Lastly, the study of exoplanets, like K218b, pushes the boundaries of our search for extraterrestrial life. The detection of biosignature gases, such as dimethyl sulfide, is an exciting prospect, though scientists remain cautious. While the presence of these molecules is compelling, further research is needed to confirm their origin and determine if they are indeed produced by living organisms. The possibility of finding life outside Earth has profound implications not only for science, but also for our understanding of humanity's place in the cosmos. In conclusion, the James Webb Space Telescope has opened a new chapter in astronomy, unveiling phenomena that challenge our current models and offering insights that promise to reshape our understanding of the universe. Its discoveries serve as a reminder of the vastness of the cosmos and the boundless potential for exploration and discovery that lies ahead. The journey to understand the universe is far from over, and with tools like the James Webb Space Telescope, we are poised to uncover even more of its secrets in the years to come.